this is the lecture number 3 for the chapter probability for the class 10th, and we have discussed up to question number 15 in the last lecture, and we are starting with the question number 16 now. Now it is given that there are 144 pens, out of which 12 are defective and 132 are good pens. So total sample space will be equal to 144. Now in the first part you have to find the probability that the pen should be good. So how many good pens are there? 132. So the NE will be equal to 132 and NS will be equal to 144. Matlab sample space is 144 and the number of events is, or the favorable events are 132. So let us call it E. So NE will be equal to 132. So the probability of getting a good pen is NE upon NS, that is 132 upon 144. Now in question number 17, it is given that the total bulbs are 20 and out of them 4 are defective. So naturally, how many will be not defective? Naturally, it will be 20 minus 6, it will be equal to 16. So you have to find the probability that it should be a defective bulb. So let E be the event that the bulb should be defective. So NE will be equal to 4. Naturally, NS will be equal to 20 and the probability of E will be NE upon NS, which is equal to 4 upon 20, that is 1 upon 5. So this is the question number 17. Now in question number 18, you read it carefully. Question number 18. Now there are 90 discs are there on which the numbers are written from 1 to 90. So naturally the sample space will be 90. Sample space will be NS will be equal to 90. Now in the first part you have to find the probability that it should be a 2-digit number. So the 2-digit number starts from 10. So from 10 to 90, how many 2-digit number will be there? From 11 to 90 there are 80 and plus 10, that is 1. That is 81 are the 2-digit number from 1 to 90. So the probability, let the event be E, the 2-digit number, and NE will be equal to 81. So the probability of this event E is NE upon NS, which is 81 upon 90. 81 upon 90, that is 9 upon 10. This is the first part. In the second part, you have to find the probability that it should be a perfect square. So the perfect squares from 1 to 90 are 1, 4, 9, 16, 25, 36, 49, 64 and 81. That is 1 square, 2 square, 3 square, 4 square, 5 square, 6 square and 9 square. So there are 9 perfect square from the number 1 to 90. So let F be the event that it is a perfect square and NF will be equal to 9 and the probability that it will be a perfect square is NF upon NS, which is equal to 9 upon 90, that is 1 upon 10. In the third part, you have to find the probability that a number should be divisible by 5. So first of all, write the number which is divisible by 5 from 1 to 90. So 1 to 90, there are 5, 10, 15, 20, 25, 30, 35 and so on up to 85, 90. So 5 to 90, the number which is divisible by 5, that is from 1 to 90, they are 18. You can take your own time to count how many numbers are there divisible by 5 from 1 to 90, they are 18. So NG I have taken as the event that it is divisible by 5. So NG will be equal to 18 and the probability of this event is 18 upon 90, NG upon NS. This is the question number 18, third part. Now in question number 19, a die is given which is not a fair die. In place of 1, 2, 3, 4, 5, 6, the alphabets are written, that is A, B, C, D, E, A. On 6 faces it is written. Now you have to find in the first part the probability that the event of getting an A. Event getting an A. So how many events of getting an A? Let I call it equal to E. So the number of events are A here, A here. There are 2 A's on 6 faces. So that is NE is equal to 2. And sample space is naturally 6. The probability of getting A will be 2 upon 6. Now in the second part, you have to find the probability that it should be of getting a D. So how many D are there in 6? Only 1. So the probability of getting a D is 1 upon 6. 1 upon 6 is the probability of getting D on a die which is written A, B, C, D, E and A. Now in question number 20, there's a figure is given. There's a rectangle whose sides are 2 by 3. So its area is 6 meters square. Now you have to find there's a circle drawn inside this rectangle whose radius is half. Now you have to find the probability when a die is thrown that it's will lie on the circle. That it means you have to find the probability of getting the area of the circle, that is pi r square. Pi r square, r here is half, so pi upon 4. Now the probability will be NE upon NS, that is pi upon 4 upon 6, which is pi upon 24. Yes, question number 21. Now there are 144 pens, total pens, and a girl will buy a pen when it is only good. There are 20 defective pens. So how many good pens are there? 144 minus 20 good pens. 20 defective pens are there in this 144 pens. So good pens are 144 minus 20, that is 124. Now the girl will buy the pen only when it is good, and let E is the event that it is a good pen. So NE will be equal to 124, and the probability of getting or buying a good pen is 124 upon 144. 124 is a good pen, 144 a total pen, that is 31 upon 36. And the probability that she will not buy it is E naught. That is 1 minus probability that she will buy the pen. That is 1 minus 31 upon 36, like this. Or you can do it directly. If there are 20 defective pens, so she will not buy if it is defective, that is 20 upon 144. Or you can do it like this. Find the probability that it is a good one, and the probability that she will not buy means that the pen should be defective. So it will be obtained by subtracting from 1 the probability that she will buy. She will not buy equal to 1 minus probability that she will buy. Now read the question very carefully. Question number 22. It is a somewhat long question. It is given that a pair of dice is thrown. The pair of dice is thrown. So in the beginning of the chapter, when we were discussing the sample space, I was discussed there that the sample space when a pair of dice is thrown is 36. 6 into 6, that is 36. What are they? I've explained to you very in detail. That is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 and so on up to 36. That is 6, 6. Now you have to find the probability of getting a sum 2, sum 3. Sum means the sum of the digit on the two faces of the die. That is, if two dice are thrown and if we get 1 on the one die and 1 on the second, the sum of the digit is 2. So the minimum sum of the digits on a pair of dice is 2 and the maximum sum of the digit will be 12, that is 6 plus 6. So the sum can be from 2 to 12 in a pair of die when it is thrown once or when a die is thrown 2 times. So let E1 is the event that the sum is 2 and that event is only 1, 1. 1, 1 means 1 and 1 on both the die. So event is only 1. I have called it E1. So 1 upon 36 is the probability of getting a sum as 2. Now let E is the event of getting a sum as 3. Now how can we sum as 3 on the pair of die? That is 1 on the first and 2 on the second, and or 2 on the one and 1 on the second, that is 1, 2, 2, 1. The number of events are 2. The probability of getting a sum as 3 is 2 upon 36, but the sample space is 36. It is 1 upon 18. Let E3 be the event that the sum is 4. So how can be the sum 4 on the pair of dice? The number can be 1, 3, 3, 1 or 2, 2. So how many events are there? 3. So NE3 is equal to 3. I have let it E3 be the event that the sum is 3. So the probability of this event is 3 upon 36. Now fourth part is the sum of the two faces of the die is 5, so the pair can be 1 4 4 1, 2 3 or 3 2. So how many events can be there? It is 4. The number of event of E4, that is the sum is 4, is 4. That is 4 upon 36. Let E5 be the event of getting a sum 6. Now how can be the sum 6 in the pair of dice? It can be 1 5 5 1, 2 4 4 2 or 3 3. So how many events are there? 1 2 3 4 5. That is 5 upon 36, but the event is 5 and the sample space is 36. Now let E6 be the event of getting a sum 7. So how can we get a sum 7 on a pair of dice? It can be 1 6 6 1, 2 5 5 2, 3 4 4 3. So how many events are there? 1 2 3 4 5 6. So the number of event of this will be 6, and the probability of this will be an E6 upon NS is equal to 6 upon 36, which is equal to 1 upon 6. Now let E7 be the event of getting a sum 8. The sum 8 can be like this on the pair of dice: 2 6, 2 on the first die, 6 on the second, or 6 2, or 3 5, or 5 3, or 4 4 on both the die. So 1 2 3 4 5. So 5 events are there. So the probability of getting a sum 8 will be 5 upon 36, because the sample space is 36. Now let E8 be the event of getting a sum 9. So 9 can be like this: 3 on the one die and 6 on the other, or 6 on the first, 3 on the other, or 4 5 5 4, like this. That is a pair of this. So the how many events are there? 1 2 3 4. So number of event of this getting a sum 9 is 4. So the probability of this getting a sum 9 is 4 upon 36, that is 1 upon 9. Let E9 is the event of getting a sum 10. So it can be 4 6 6 4 5 5. So how many events are there? 1 2 3. That is 3 upon 36 will be the probability of getting a sum 10 when a pair of dice is thrown once. Let E10 be the event of getting a sum 10. So the event can be 4 6 6 4 5 5. So how many events are there? Only 3. So 3 upon 36. Let E11 be the event of getting a sum 11. So how can we get 11 as the sum? 6 on the first die and 5 on the second, or 5 on the first and 6 on the second. So how many events are there? Only 2. The probability of getting a sum 11 will be 2 upon 36, that is 1 upon 18. E12 be the event of getting a sum 12. So let us call it 6 6. Only one event will be there to get a sum 12. So 1 upon 36 is the probability of getting a sum 12 when a pair of die is thrown once. So this is the first part of question number 22. In the second part, it being asked whether the probability is equally likely. We know they are not equally likely because the probability of each of them is different. Now in question number 23, a coin is tossed thrice or 3 coins is tossed once. Now the sample space, we know it: head head head, head head tail, head tail head, head tail tail, tail tail tail, tail head tail, tail tail head, tail head head. So there are 8 events. Now a person will lose if he is not getting same on both the coins, or yeah, all the coin shows the same result. That is, he or she will lose if all heads or all tails are there. So it means he loses if he will get head head tail, head tail head, head tail tail, tail head tail, tail tail head and tail head head. तीनों पे हेड या तीनों पे टेल आने पर वो जीतेगा. तो हारेगा कब? जब ये हेड 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 और टेल 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 ना आए. तो हारने की प्रोबेबिलिटी पूछी जा रही है. तो 1 2 3 4 5 6, देयर आर 6 इवेंट्स. So the probability that he will lose will be 6 upon 8, that is 3 upon 4. This is the probability that he will lose. Now in question number 24, a pair of dice is thrown, and you know that the sample space for the pair of dice is 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 2 4 2 6 up to 6 6. Their sample space is 36. Now in the first part you have to find the probability that 5 will not come on either die. किसी भी die पर 5 नहीं आए, 5 नहीं आए. तो वो कितनी इवेंट्स हैं? तो इसमें कौन कौन सी इवेंट नहीं आएगी? देखो 1 5 नहीं आएगा, 2 5 नहीं चाहिए, 3 5 नहीं चाहिए, 4 5 नहीं चाहिए, 5 1 5 2 5 3 5 4 5 5 5 6 नहीं चाहिए और 6 5 नहीं चाहिए। ये वाली वो इवेंट है जिसमें हमें 5 नहीं चाहिए। तो how many events are there? You can count it easily. There are 25. So the probability of not getting a 5 on either die will be 25 upon 36. E2 बिल्कुल इसका opposite है. That is the probability. Let E2 is the probability that 5 will come on at least once. तो या तो आप इसको 1 में से माइनस कर दें तब भी आंसर आ जाएगा, या you do it directly that 5 will come at least once. तो किस किस में कम से कम एक बार 5 आएगा? 1 5 में आएगा, 2 5 3 5 4 5 6 5 5 1 5 2 5 3 5 4 5 5 5 6। तो ये टोटल 11 इवेंट्स हो गई, 11। So the probability of getting 5 at least once is 11 upon 36। ये आंसर इस वाले को 1 में से माइनस करके गया, बिकॉज they both are complementary events. Now in question number 25, a coin is tossed twice. Now the probability of getting 2 heads, कितना है यहाँ पर 2 heads? एक ही बार आ रहा है तो 1 upon 4। द probability of getting 2 tails, यहाँ पर भी एक बार आ रहा है 1 upon 4। एंड द probability 2 tails आने की probability केवल एक ही बार है यहाँ पर 1 upon 4। एंड द probability of getting 1 head और 1 tail, एक head और एक tail 2 बार आ रहा है तो 2 upon 4। So they are not equal to each other. Now if a die is thrown once, तो क्या probability even और odd नंबर आने की सेम है? हाँ सेम है, क्योंकि odd नंबर में कौन कौन सी इवेंट होती है? एक डाई में 1 3 5। तो ये कितनी इवेंट हो गई? 1 2 3 3 upon 6 1 upon 2 आ गया। तो odd नंबर आने की probability डाई में कितनी है? 3 upon 6, दैट इज 1 upon 2। इस तरह से इवन नंबर आने की probability भी क्या है इन डाई पर? 2 4 6, तो उसकी probability भी कितनी है? 3 upon 6, दैट इज 1 upon 2। तो इसका मतलब सेम है, एक डाई में इवन नंबर और ऑड नंबर आने की probability बराबर बराबर है, जो कि 1 upon 2 है। तो ओके स्टूडेंट, दिस इज द कंप्लीशन ऑफ द चैप्टर probability of the class 10th। ओके, थैंक यू।